Good day to you wherever you are. This is Kerry Hamill with Conservation Biology EVSP 417 at American Military University, and today our subject is, what are our wetlands worth? So how much are our wetlands worth? To understand the value of our wetlands, we must first understand what a wetland is, and we must also be able to understand what the services are provided by wetlands. Wetlands are a natural area that is often wet but doesn't have to be wet all year. Wetlands are salt marshes, swamps, low-lying floodplains for rivers, streams, low areas around lakes and ponds, mangroves, peatlands, and coastal reefs. Wetlands play a pivotal role in the overall water, soil, and air quality of the numerous ecosystems surrounding them. A key example of the cleansing function of wetlands is water filtration. When surface and groundwater runoff enter a wetlands ecosystem, the flow of water is drastically slowed. Because of the multitude of diverse plants in an ecosystem, the slowed water sediments are deposited into the wetland. The settled sediments are absorbed by plant roots and microorganisms on and below the wetland's floor. Excess nutrients such as nitrogen and phosphorus from residential and agricultural fertilizers are absorbed by the plants and thus removed from the water that eventually percolates or drains off from the wetlands. Wetlands can be a natural solution to wastewater management. In 1990, city managers for the city of Phoenix, Arizona, needed to upgrade their existing wastewater treatment facility. Their initial estimates for upgrade to existing facilities exceeded $635 million. This was the beginning of 12-acre Tres Rios demonstration project. The proposal suggested that man-made wetland could sufficiently clean the discharged water and provide much-needed habitat for birds, including numerous endangered species, at a much lower cost. This program continues to serve Phoenix successfully and has led to the development of hundreds of manufactured wetlands for final water treatment to date. Wetlands also serve as a flood control barrier. This is accomplished through soaking and retaining stormwater. A wetland ecosystem typically can store approximately 1 million gallons of water. In coastal areas, barrier islands, coastal marshes, forested wetlands, and mangroves also serve to protect against wind and storm surges from hurricanes and typhoons. The plants in these ecosystems provide vital adhesion that prevents erosion of coastal soils. Recreation is also a service provided by wetland ecosystems, as wetlands are often sought out for hiking, fishing, hunting, birdwatching, photography, and much more. To understand what wetlands are worth, we must first understand how we value our wetlands. And there's two types of uses that we will define. It is use value and non-use values. Under use values of ecosystems, we first describe the direct use value, which is the valuation that an ecosystem serves as a tangible benefit to the end user, such as direct recreational uses, mineral extraction, timber extraction, or directly receiving a good or service from an ecosystem. Indirect use values is the intangible or indirect benefits that a user receives from an ecosystem. An example of this is a tax-funded mangrove restoration or rehabilitation, where some taxpayers may actually never visit a mangrove, but the mangroves can provide them with protection from wind, storm surges, erosion protection, and pollutant extraction from the result of hurricanes. While those people didn't have a direct use for the mangrove, they did receive indirect benefits from its presence. Now that we've covered use values, we're going to look into our non-use values. So the first of the non-use values that we're going to cover is the bequest value, and that is the value that a community places on an ecosystem and its availability for future generations. Next, we have the existence value, and it is the value that an individual or community places on knowing that an ecosystem is in existence. And the last of the non-use values is the option value, which is the value of being willing to pay to have the option of use. It's the willingness to pay for the ability to use such options as hiking, camping, hunting, fishing, or any other use of a particular ecosystem. Economic valuation encompasses many types of economic values that are also correlated to each use value category. On our next slide, we'll have a table that shows numerous examples of economic valuation methods that are listed along with their description and then the use value or values that they correlate to. As you can see, there's many different economic valuation methods listed in this table. The first one we have is market analysis, where the market prices of outputs and inputs are available. Marginal productivity, net of human effort and cost, could approximate with market price of close substitute, and it requires shadow pricing. And this is linked to direct and indirect use values. Productivity losses, which are a change in net return for marketed goods, a form of dose response market analysis, again, correlates to direct use and indirect use values. Production functions, wetlands treated as one input into the production of other goods based on ecological linkages and market analysis. Production functions are directly linked to indirect use values. Public pricing, which is public investment, for instance, via land purchase or monetary incentives, as a surrogate for market transactions, correlates to all three, the direct, indirect, and non-use values. Hedonic price method is our next selection, and it is a derivative of implicit price for environmental good from analysis of goods for which markets exist and which incorporate particular environmental characteristics. This is directly linked to direct use and indirect use values. Contingent valuation method, construction of a hypothetical market by direct surveying of an example of individuals and aggregation to encompass the relevant population. It has the problems of potential biases, and it again, direct, indirect, and non-use values that it is correlated with. Damage cost avoided. It is the cost that would be incurred if the wetland functions were not present. Example given would be a flood prevention. It is an indirect use value. Defensive expenditures. Cost incurred in mitigating the effects of reduced environmental quality, represents a minimum value for the environmental function, and it is an indirect use value. Relocation costs are expenditures involved in the relocation of affected agents or facilities. A particular form of defensive expenditure, again, is an indirect use value. And the next one is replacement substitute costs, which is a potential expenditures incurred in replacing the function that is lost, for instance, by the use of substitute facilities or shadow projects, and it correlates to direct use, indirect use, and non-use values. Last is the restoration costs, the cost of returning the degraded wetland to its original state. A total value approach, important ecological, temporal, and cultural dimensions, and it correlates to all three use values. So now that we talked about the economic value evaluation methods, we're going to talk about actual monetary values placed on ecological services provided by our wetland ecosystems. So in a document released by the North Carolina Cooperative Extension in 1997 in conjunction with North Carolina A&T State University and North Carolina State University, wetland ecosystems are valued at $33 trillion per year. In comparison, that year, the gross national product was only $18 trillion. The value total for all wetlands in the U.S., as in the average per acre, was approximately $6,000 per wetland acre. Evaluating an itemized breakdown of the ecosystem economic value broken down by the following categories of monetary values per acre. Wastewater treatment was valued at $1,690. hydrological regulation was